In Chapter 2, we are going to look at simplifying expressions and solving equations. So with simplifying expressions, the first thing we need to notice are terms. And terms have the same variable part are called like terms. And there also means that they have the same variable raised to the same power. So some examples would be 8x, 2x, and 4x. Those are all like terms because the variable is x and the power that these are each raised to is 1. Here are two like terms, x squared and 3x squared, because they both have an x and it's both raised to the squared. Here are terms that are not like terms, a squared and b squared. Those are not like terms because they do not have the same variable. And x and x cubed are not like terms because they are not raised to the same power. So when we have like terms, we can add them by adding or subtracting the coefficient. And the coefficient is always the number that is found in front of the variable. So this coefficient would be 8. This coefficient would be 2. That coefficient would be 4. This coefficient would be 1 because that's really saying 1x squared. And this coefficient would be 3. So when I combine like terms, there's the coefficient, that's 8. There's the variable, that is x. So if I'm looking at combining like terms, there's 8x plus 2x plus 1x. I combine them all. I add the coefficient, so 8 plus 2 is 10, plus 1 gives me 11x. Here, if I have 5x squared minus 3x squared, I'm going to really just look at the 5 minus 3, and I get 2x squared. One way that can help you sometimes is to circle and cross off if that helps. So if I'm looking at 8x plus 1 minus 3x plus 2, I can say, hey, 8x is going to be combined with the negative 3x. You want to be really careful. This negative stays with the 3x. So that's going to give me a 5x. And then I could cross that out. And then I have a plus 1 plus 2, and that gives me a nice grand total of plus 3, and then I could cross those out when I'm done. And that is one way to combine like terms. Now, sometimes when we're combining like terms, you may want to apply the distributive property before combining your like terms. So in this case, I have 3 times parentheses 2x plus 1 minus 2 plus 1x. First thing I'm going to do is combine that 3. So using my distributive property, 3 times 2x gives me 6x, and 3 times 1 gives me 3. Then I have a minus 2 plus 1x. So now here total I have 6x. I look for the like term. Oh, there's a positive 1x over here. So 6x plus 1x gives me a grand total of 7x. And 3 minus 2 gives me 1. So my answer is 7x plus 1. Now you want to be careful with problems that have negatives. In this case it said 2 minus 3x parentheses x plus 1. And one way to help you do this is if you put a circle, and remember that negative goes with the 3. And when I use that distributive property, I'm going to distribute that negative as well. So that will get distributed to the x, and it will also get distributed to the 1. So when I distribute that, negative 3 times x gives me a negative 3x, and negative 3 times a positive 1 gives me a negative 3. Now I've done my distributive property. I can combine my like terms. Well, 2 has a like term of a negative 3. That negative stays with the 3. So 2 minus 3 gives me a negative 1, and then that negative 3x doesn't have any other term to combine, so there is our answer. So here's another example to look at. We have 3 times parentheses x plus 1 minus 2 times parentheses x minus 2 plus x plus 2. So I'm going to use distributive property first, so that 3 is going to get distributed to the x, so that gives me 3x. 3 gets distributed to the 1, so that gives me a positive 3. The negative 2 gets distributed to the x, so that gives me a negative 2x. And the negative 2 gets distributed to the negative 2. Negative times a negative is a positive, so that becomes a positive 4. Then I have plus x, then I have plus 2, and that just stays. I'm going to find all my terms that are like terms to the 3x. So 3x, a negative 2x, that negative stays with the 2, and a positive x. Well, 3x minus 2x gives me 1x, and then I add one more x, gives me a grand total of 2x. So when you just see just an x there, that's really the same thing as saying 1x. Don't forget that. Then I have a plus 3 plus 4 plus 2. That gives me a grand total of plus 9. Notice we usually write our answers with the largest exponent first and work our way down to the smallest exponent. Next, we'll take a look at something called the value of an expression, and the value of an expression depends on what number you assign to the variable. So, for example, here's 2x plus 3, and I say, hey, find the value of the expression when x equals 3. Well, that means I'm just going to substitute a 3 in for x, so when I did that, I got 2 times 3 plus 1. Well, using my PEMDAS rules, I'm going to do 2 times 3 first, that gives me 6, I add 1, and I get 7. So here's another example, a squared minus 3, let a equal 2. So I'm going to substitute a 2 in for a. That means 2 squared minus 3. Well, 2 squared is 4 minus 3. That gives me 1. And here are 2 more examples to look at. Notice the difference in these. I have x squared minus 1 when x equals a negative 2. Well, if x is a negative 2, I'm going to substitute a negative 2 in for that x. That means all of that negative 2 gets squared. So negative 2 times negative 2 is a 4. And then we have minus 1, and 4 minus 1 gives me 3. Well, take a look and see how that's different from this problem. This says negative x squared minus 1 when x equals a negative 2. So again, I put the negative 2 in for x, and all of negative 2 is going to get squared. But this negative is still out here, and that negative is not getting squared. So that leaves me with a negative from here, 4, this turned into just a positive 4, minus 1, and that gives me a negative 5.